This video is designed to help you become more comfortable with going back from points back to finding the equation of a line. What we've been doing thus far has been taking equations and making graphs, finding points, finding spots, inputs, outputs of functions, and graphing them afterwards. What we want to do now is work our way backwards, find the equation given the information. So, given 2 points that are going to make the equation of a line, the first thing we want to do is remember that we need to identify the slope. One of the two major things we need in order to write the equation of a line is to tell us somewhere to go. So if we take our slope equation with our 2 points, 3 minus 2, that's y2 minus y1, over x2 minus x1, we can get an equation or a slope of negative a half. Again, that's going to tell us that if we draw the line from 2, 3 and 4, 2, that we've got a slope going down 1, right 2, consistently to form our line. Or, if we put that negative on the top, we could go up 1, left 2, sorry, negative on the bottom there, up 1, left 2. And again, forming that nice straight line to help us draw a nice line through our 2 points. Now the only other thing we need in order to write the actual equation of the line is to help define that y-intercept. So one thing we can do is take one of our 2 points, and I'm just going to grab the point 4, 2, and plug that into our y equals mx plus b equation for y and x. We don't know what the b is, but since we do know the slope, we can plug in that negative half, and 2 will be equal to negative 2 plus b. b equals, if we add 2 to the other side, 4. And we can define that line as y equals negative 1/2 x plus 4. And we can always double check our graph and make sure that at y equals 4, that was where we actually crossed the y-axis. Go ahead and use that same approach for the 2 points on the left and find a y equals mx plus b equation through those 2 points. When you're finished, feel free to take your calculator, graph the equation on your graph, check your table, and see if the 2 points don't happen to occur on the table of your graph. Okay, so you'll see that I laid it out for you here. The slope, it comes out to negative 1. Plugged in my slope, took the second of the 2 points, plugged in for x and y, figured out that b needs to equal 6, so y equals negative x plus 6 should be my slope-intercept form of my equation. I also went ahead and typed it into the calculator. I just opened up a graphing page, typed in f1 of x is negative x plus 6. Again, pressed Control T to open up the table, and you'll notice that 8, negative 2, and 12, negative 6, the 2 points that we used, are on my graph. So it looks like we're good. Another way to organize our equation is in what's called point-slope form. Y minus y1 equals m times x minus x1. Again, any straight line is really just somewhere to go, our slope, and somewhere to begin. Instead of beginning at the y-intercept, we're now going to begin at any random x1, y1 coordinate. So again, the first thing we do want to do is find our slope. I'm going to say 8 minus 6, 4 minus 10, and end up with a slope of negative 2/3. But now, in point-slope form, I don't have to do quite as much work. Y minus, and again, I'm just going to pick my second point, doesn't matter first point or second point, but y minus the y-coordinate equal to the slope of x minus the x-coordinate, and you are already in point-slope form. You could also convert this very quickly to slope-intercept form if you really wanted to. All you have to do is distribute your slope. So negative 2/3 x plus 20/3, and then add my 6 over to the other side. Realize that I'm going to have to do that in thirds, but 6 is the same thing as 18/3. So if I add 18/3 to both sides, I'll essentially be canceling off my 6 over here on this side and get a slope of negative 2/3 times x plus 38/3 over here. And that would be the exact same equation If we graph that, we should still end up going through the points 10, 6, and 4, 8. Go ahead, take that same approach, take the 2 points given, and see if you can find a point-slope form equation for your line. Okay, hopefully you ended up with the same equation that I did. Remember, if you use the other point, 3 and 29, you would just have a 29 in place of the 4, and a 3 being x minus 3 in place of that x plus 2. However, if you converted it to slope-intercept form, we should have both ended up in the same place, y equals 5x plus 14, which I quickly again typed into my calculator and found that negative 2, 4 and 329, you'll notice, get that to move down, are both on my graph. So we know we did it right. Now on the right are the type of problem you might also see related to this idea. Find the equation of the line perpendicular to the given equation, but through the given point. So where we chose negative 2, 4 over here on the left, that's where we're going to use our point at 4, 3. However, in order to get our slope, instead of using our slope equation, we're going to look at this given equation. Since the slope of that equation is m equals 5, the slope that we're going to use is the perpendicular slope. So our slope is going to be negative 1/5. Now it didn't say which type of equation to form, so let's go ahead and start with point slope form, and again we'll convert it into y equals mx plus b, or slope intercept form. So let's start off with y minus 3 equals the negative 1/5 x minus 4. Technically, that would be a perfectly good equation to end with, since we weren't instructed otherwise. But if we want standard form, or we want slope-intercept form, sorry, we can quickly distribute our negative 1/5, making a positive 4/5 there, and then add 3 over to the other side. Y equals a negative 1/5 x. 4/5 plus 3, 3 being equal to 15/5, means that I'm going to add 15/5 to the 4/5 and get 19/5. And that should be also a perfectly good answer. On the next page, just 2 more practice problems real quick. Use that same idea to help with making a parallel line, or again, another perpendicular line. I'll post the answers in just a little bit, so go ahead and pause the video, and you can find the answers now. Alright, there are your 2 answers for you. Again, we just had to find the slopes that would apply correctly. Parallel line, first of all, I solved for y, so that I knew that I was in y equals mx plus b form. If I'm going to do a parallel line, hang on to that slope of 3, plugged in my point. This would be a perfectly good answer again, but again, if you want to distribute your 3 and add your 9, here is your y equals mx plus b formed equation at the bottom. Over here at the right, same equation, so solving for y, same idea, slope was 3, however this time we want to be perpendicular, so use a slope of negative 1/3, plug in our point, and quickly figure out that y equals negative 1/3 x minus 6 will be our final answer. I hope that helps you finding equations of lines. Good luck, and have fun.